In this video, we gonna talk about the total differential. The total differential will be the differential for calculus of several variables. So we gonna have z equal to fxy. It's gonna be the function in two variables x and y. Okay, so as you can see that the differential turned out to be, you have to take care two variables. So it's gonna be x and y. So you're gonna have delta x and delta y, and delta x will be the change in variable x, and delta y will be the change in variable y accordingly. And the word total differential will be dz. Dz turned out to be, normally you're gonna have, if you recall, okay, so the differential will be just y equal to fx, and you have dy equal to f prime x dx. So you have the derivative of the function. However, in the several variable or two variable case, you're gonna have fx and fy, so you're gonna have the partial derivative. So you see that you have partial derivative with respect to x, and you have the partial derivative with respect to y accordingly. So you're gonna see that the total differential will take care both variable. So you're gonna see the change in x dx, and you're gonna have the change in y dy accordingly. Okay, so this is the definition of the total differential. And the total differential provides us with an approximation of the exact change in delta z. So the delta z will be f x plus delta x, y plus delta y. So you see that it's going to be kind of same thing. However, if you are having the one variable case, you're not going to see the variable y. So it's going to be fx plus delta x minus fx. Okay, so here it's going to be taking care two variables, x plus delta x and y plus delta y. Okay, and you have fxy. So it's going to be the net change delta x in x. So it's going to be exchanges from x to x plus delta y, and y from y change in y. So it's going to be from I have a mistake, a net change in y from y to, okay, so it's going to be from y to, so it's going to be from y to y plus delta y. Okay, so that is going to be same thing, the yellow approximation that we have in the previous lecture. So it's going to be delta z is about dz. So it's going to be dz dx plus dz dy. Okay, so let's do one example. So you're going to have z equal to fxy equal to xy minus 3y squared. The question asks you to find delta z and dz. So you're gonna first find dz. Okay, let's first find delta z. So delta z in this case turn out to be fx plus delta x, y plus delta y, minus fxy. Okay, so you're gonna have fx plus delta x, y plus delta y. So it's going to be f, and in this case you have x at 1, 2, and delta x is 0.1, delta y is 0.2. So it's going to be 1 plus 0.1 and 2 plus 0.2. Okay, sorry, 0.01. and 2 plus 0.02, okay, and you have minus 1, 2, okay. So in this case, you get f 1.01 to 0.02, subtract f at 1, 2, and you can evaluate this guy. So this guy will be just, you're gonna plug in x equal to 1.01 and y equal to 2.02. So it's gonna be 1.01 times 2.02 minus 3 2.02 square. Okay, so it's gonna turn out to be kind of something funny to compute, and it's gonna be subtract by the term that quite simple. So it's gonna be 1 times 2 minus 3 times 2 square. Okay, and you see that you may have to take out a calculator in order to do this one. So you see that this guy will give you 2.0402, okay, minus 3 and 2.02 square turned out to be 12.2412. Okay, so this one will be the first parenthesis, and you subtract by this number. This number turned out to be simple, so it's going to be 2 minus 12. So it's going to turn out to be 2 minus 12. Okay, and it's turned out to be, the total one turned out to be equal to, it's going to be, let me just calculate this one for you. So it's going to be negative 0.201. Okay, so this one is not quite simple. You may have to take some time in order to evaluate this guy. And this one is going to be like a true chain or actual chain for delta set. Okay, and if you compute d set, if you compute d set, it's going to be just the derivative fx dx plus fy dy. So it's going to be the partial derivative with respect to each variable x and y. And you see that you have fx. Okay, so let me compute fx. Fx, it turned out to be your derivative with respect to x is going to be y. And you have fy, the derivative with respect to y. So you did with respect to y, you would get x minus 6y. Okay, so you're gonna take care. So it's gonna be x, it's gonna be y dx plus x minus 6y dy. Okay, so you just use these two derivatives down here. Okay, and then what? And then you're gonna just plug in dz. So you have delta x to be dx. So this guy will become dx. So it's gonna be this, in this approximation, this one is gonna be delta x and delta y when dx, when delta x and delta y turn out to be kind of small. Okay, so you're gonna just plug in. Okay, so you're gonna put x equal to 1, y equal to 2. Okay, let me write them. Okay, so you're gonna put x equal to 1, y equal to 2, and delta x equal to 0.01, delta y equal to 0.02 into this equation in order to obtain dz. So you're gonna have 2, and delta x is 0.01, okay, plus x is 1 minus 6 times 2, and delta y is 0.02. And you see that this guy turned out to be a simple number that allows you to compute quite easy. So this guy is going to be 0.02, and this one is going to turn out to be 11. So it's going to be plus negative 11, 0.02. So this one becomes 0.02 minus 0.22, and this one will be negative 0.2. Okay, so you can see that the comparison that you have for the first term, the first one, you see the final answer is the actual value. Okay, so this one I would say that this guy gives us actual change. However, it's kind of messy to compute down here, okay? And this one is going to be the approximation of change. So this one is going to be approximate change. And you see that this one, the approximate chain turned out to be very close to the actual chain. And this one is going to be kind of easier to compute. Okay, and this one is called the total differential. Okay, so the green guy here is called the total differential. Okay, so this one will be just the one that we can use in order to find the approximate chain for the function in two variables x and y. The second one, again, we have fxy equal to x over x minus y, and you like to approximate the chain, okay, from f negative 0.2, so 0.3, negative 3.02, negative 1.99 minus f negative 3, negative 2. So in this case, you're gonna see that you must know first that it's gonna be negative 3, okay, minus 0.02, and this guy is gonna be negative 2 plus 0.01, and this will allow you to obtain delta x and delta y respectively. Okay, so you see that this amount turned out to give you delta x and delta y. Okay, and negative 3 will be your x and negative 2 will be your y. Okay, so you need f negative 3, negative 2. Okay, so you like to approximate. So this one will be your delta z. Okay, so delta z can be approximated by using the differential or the total differential dz. And the dz turned out to be fx at negative 3, 2, negative 3, negative 2 delta x plus fy at negative 3, negative 2 delta y accordingly. Okay, so this one will be the formula. So we need fx at negative 3, negative 2 and fy at negative 3, negative 2. Let me compute them. So you have your function f here. So in order to obtain fx, you're gonna differentiate. So this one, when you like to differentiate, fx is gonna be using the quotient rule. So it's gonna be the bottom derivative of the top minus the top derivative of the bottom. So it's gonna be 1, okay, over the bottom square x minus y square. Okay, so that gonna give us negative y over x minus y square. Okay, so that my fx, and fy turned out to be, so you see that fy, again, you can use the quotient rule or you don't have to use the quotient rule. Let's use the quotient rule. So you have x minus y times 0 minus the bottom derivative of the top, so it's going to be negative 1 over x minus y square. Okay, so this guy will turn out to be x over x minus y square. Okay, so this one will be your fy, and you need derivative, the partial derivative at negative 3, negative 2, and the partial derivative with respect to y at negative 3, negative 2. So in these cases, you would get what is going to be fx negative 3, negative 2. So it's going to be negative 2 over negative 3 minus negative 2 square. So this one would give you number 2, right? Yeah. This one would give you number 2. The second one will be you have negative 3 over negative 3 minus 2 square. Okay, and this one will be what? Negative 3. Okay, so you see that the denominator turned out to be just 1 square and it will disappear. Okay, so you're gonna just use them here. So it's gonna be 2, and delta x is negative 0.02, negative 0.02. Okay, and for the fy is gonna be negative 3, and delta y is 0.01, 0.01. Okay, and you're gonna just sum them up. So it's gonna be plus, and this guy will be equal to. Okay, so you see I use the color according to the calculation, and you see that this one will be negative 0.04. Okay, and this guy will be negative 0.03, and this approximation that you obtain turned out to be negative 0.07. Okay, so it means that you're gonna be able to obtain delta z equal to like a negative 0.07. And this means what? This means, okay, so this means that the approximation that you are looking for turned out to be f negative 3.02, negative 1.99, subtract f negative 3, negative 2 is about negative 0.7. Okay, so it's going to be like this, and you'll be able to compute f negative 3, negative 2. So this guy will be negative, it's going to be x, right? So it's negative 3, negative 3 minus 2 square. So it's going to be negative 3. Okay, so this guy equal to negative 3. So this allow us, if you wish, so this allow us to obtain the approximation of f negative 3.02, negative 1.99. Okay, so it's gonna be just about, okay, so you see that you allow to move this term to the other side. Okay, so you allow to move this term to other side, so you gonna get negative 3. Okay, and you gonna have negative 0.7. Okay, and this number turned out to be, okay, so this number turned out to be equal to 3 minus 0.07. So you get 2.93 to be this approximation for the value. Okay, so it's going to be about 2.93 if you wish to evaluate the green guy. Okay, so if you wish to evaluate f negative 3.02, 1.99 negative is going to be 2.93, okay, without doing the messy calculation, okay. The second one, you have, okay, with me so far, you need to, I know that it's going to be too many information to gather, okay. We did already 2 examples. The next one that we're going to do is going to be, we like to approximate square root 3.05 square minus 1.97. So this one look like, okay, so this one look like square root of x squared minus y to the third. Okay, so it's going to be, it look like square root of x squared minus y to the third. So we gonna just let that equal to fxy equal to this function. Okay, and we see that you have the square root 3.05 square. Okay, so let me analyze this one a little bit. So it's going to be square root 3.05 square minus 1.97 to the third. And this one, okay, just square root 3 point, not 3 point. So it's going to be 3 plus 0.05 square. And you have 2 minus 0.03 to the third, like this, okay? And you see your x plus delta x, y plus delta y, okay? So this allows you to see x equal to 3, y equal to 2, okay? And you have delta x become 0.05, delta y become negative 0.03, okay? So you have delta x and delta y accordingly, okay? So let me also highlight them for you. So delta x and delta y, okay, accordingly. And then what? And then this one, you need fx plus delta x, y plus delta y, minus fxy, okay? So this one is delta z. So this guy is delta z, okay? And this one can be used differential in order to give you the approximation. And this one will be fx at 3 to delta x plus fy at 3 to delta y, okay? And in this case, you're gonna have f at 3, 2, okay? So this one is gonna be, let me write down the number, also 3.05, 1.97, and this guy will be 3 and 2, okay? And you see that you need fx at 3, 2 and fy at 3, 2, okay? Let me compute them here. So you have fx equal to, okay, so you see that, let me compute fx and fy here. It's not gonna take many space here. So you have fx and fy. Fx will be, you have 1 over 2 root x squared minus 3y cubed, okay? And you have to differentiate the inside, so you get 2x. So this would give you x over square root x squared minus y cubed, okay? So that will be the fx. And for fy is gonna be again 1 over 2 root x squared minus y cubed. Okay, and you differentiate it inside, you get negative 3y squared. Okay, so this one will become, okay, so it's going to be negative 3y squared over square root x squared minus y cubed. Okay, in this case. Okay, so let me follow my solution a little bit. So you be able to obtain fx at 3, 2 by plugging in x equal to 3, y equal to 2 into this partial derivative. So you get 3 square root 3 square minus 2 to the third. Okay, so this one will be just 3. Okay, and you have fy at 3, 2 to be negative 3, and you have 2 square over square root 3 square minus 2 to the third. So you would get negative 3 square. So you would get, I forgot 2 here. So you would get negative 12 over 2, which is negative 6. Okay. So in this case, you're gonna plug in the value. So this guy will be 3, this guy will be negative 6. And for delta x, it's gonna be 0.05, and delta y is gonna be negative 0.03 into the formula, and you're gonna add them up. So this will be negative, not negative, 0.15 plus 0.18. Okay, so it's going to be 0.15 plus 0.18, and it's gonna be so it's gonna be 0.23. Okay, so this one will be 0.23, not 23, 33. Okay, and then finally let's use other color. So we know that if 3.05 1.97 minus f32 is about 0.33 that we have done so far. Let me use the pink color. Okay, so you have f32, so it's gonna be square root 3 square minus 2 to the third, so it's gonna be root 1 equal to 1. Okay, so you're gonna just move this term to the other side to obtain the final answer. So in this case, you're gonna have f3.05 1.97 is turned out to be about 1 plus 0.33. Okay, and the final answer will be 1.33. Okay, for this approximation. Okay, so this one will be the whole picture for this question. Okay, so you see that it's gonna consist of, you have to construct the function on your own. You find the partial derivative with respect to x and with respect to y. You use the approximation here. Okay, and you need the value of fx at 3, 2 and the partial derivative fy at 3, 2, and you're gonna use both of them in the formula, and you have fx delta x fy delta y, and you get 0.33, and this one will be the final answer, 1.33. So the next two questions will be like a word problem or application for this topic. Okay, so let me read the question for you. The country workshop total weekly profit realized in manufacturing and selling the row top desk is given by PXY. Okay, so this one is going to be profit. And this one stand for the profit function PXY. Okay, and X stand for the number of finished and unfinished unit manufactured sold per week. Okay, currently the weekly output is 190. Okay, so it's gonna be your X equal to 190 and Y equal to 105. Okay, determine the approximate change in total weekly profit if the sole operator of the country workshop decide to increase the number of finished to 200 per week and decrease the number of unfinished unit to 100 per week. Okay, so you see that you have X equal to 190 and you like to approximate the change. Okay, so you need delta. Okay, so you need delta sat. Delta sat is f at 200. Okay, 100. Okay, subtract, not f, I have to say p, right? So it's gonna be p at 200 minus, not minus, 100 minus p at 190, 105. Okay, so you need this one, and you see that it's kind of difficult to evaluate or difficult to do. So you need the approximation dsat. Okay, so your dsat will be px at 190, 105 delta x. Okay, so it's gonna be px delta x. Let me move this guy down a little bit. So this one will be here, and you have py 190, 105 delta y. Okay, so in this case, in order to find delta x and delta y, so this one is your x, your y. Okay, so you have increased to, so it's gonna be 190 plus 10, and another guy will be 105 minus 5. Okay, so this allows you to conclude that delta x equal to 10 and delta y equal to negative 5. Okay, so they are here ready for us. Okay, and you're gonna have to find the partial derivative px and py. Okay, let me find them up here. So you need px. Okay, so px will be negative 0.4. Okay, so it's gonna be negative 0.4 what is called. So you need px is going to be negative 0.4 delta x, negative 0.4 x, not delta x, and 0. And you have negative 0.2 y. Okay, and you have 100. Okay, so you plus 100. Okay, and you have delta y, sorry, you have py Okay, so you have py is gonna turn out to be py equal to what is called, so this guy is gonna be negative 0.5 y, okay, negative 0.5 y, and you have negative 0.2 x, okay, negative 0.2 x plus 90. Okay, so that my px and py. So you need px. Okay, so let me use, oh, I have plenty space down here. Okay. Okay, good. So you have px at 190, 105, and py at 190, 105. Okay, so you see that it's gonna be negative 0.4190 minus 0.2105. Okay, and you have plus 100. Okay, so this guy will be negative 76 plus 21, not plus 21 minus 21 plus 100. So this guy will be 3. Okay, not bad. And negative 0.5190, negative 105 here, 190 plus 90. Okay, so this one will be negative 38, okay, minus 52.5 plus 90. So this guy will be negative 0.5. Okay, so in this case, you would get what? You would get 3, and delta x will be 10. Delta x will be 10. Okay, and you have this guy which is negative 0.5. Okay, and delta y will be negative 5. Okay, and you're gonna kind of sum them up. Okay, so you're gonna sum these two numbers up. So in this case, you would get, okay, 30. So you would get 30. Okay, plus this guy will be 2.5 negative. Okay, so it's gonna be 2.5. So it's gonna give us 32.5 to be the chain. Okay, so the next one, we like to find the productivity of a South American country is given by the function fxy equal to 20 x to the 3/4, y to the 1/4. So when x is the unit of labor and y is the unit of capital are utilized, we like to find the approximate change in output if the amount expended on labor is decreased from 250 to 240 to 54, and the amount of expended capital is increased from 16 to 18 unit. Okay, so for this one, you're gonna have fxy. Okay, so you like to have f to 15 to 50 16 minus f 16, okay, 18. Okay, so you like to have delta z, and this one, sorry, So it's going to be 240, 18. Okay. So you like to approximate, sorry, I right switch. So you like to find delta set equal to F 240, 18, subtract by 256, 16. Okay, so you see this guy 250 to 240, 256 to 254, and 16 to 18. Okay, so in this case, you like to find this one, and this one will be approximate by using dz. And you see also that this one is 256 minus 2, and you have 16 plus 2. So you can conclude that delta x equal to -2 and delta y equal to 2. Okay, and this guy will be, okay, so, and this guy will be, you have if x at 256, 16 delta x plus fy at 256, 16 delta y. Okay, so you have something like this first, and then what? And then we need to compute the partial derivative with respect to x and the partial derivative with respect to y. So partial derivative with respect to x is, let me try to calculate them here. So it's going to be 20, and you have 3/4, x to the -1/4, y to the -1/4. Okay, so that will be the partial derivative with respect to x, and the partial derivative with respect to y will be 1/4, x to the 3/4, y to the -3/4. Okay, and this one will be fx at 256, 16. Okay, so this guy will turn out to be 5 here, so it's going to be 15, and it's going to be x over y, so it's going to be 16 over 256 to the 1/4. Okay, and it's gonna be what number I would have. It's gonna be 16 divided to 50. So this guy will be 15 2 over. So it's gonna be, I would say that it's gonna be 4, right? Yeah, it's gonna be 4. So it's gonna be 15 over 2. Okay, and you have fy to 56, 16. Okay, so here again is 5, so it's going to be 5 and 256 over 16 to the 3/4, so it's going to be 5, 4 over 2 raised to the 3rd power, so it's going to be 5 times 8. Okay, so in this case you have fx and fy, so you have 15 over 2, 15 times 8. Okay, so you're gonna have, okay, so you're gonna have 15 over 2, delta x is -2, plus, okay, you have 15 times 8, delta y is 2 times 2. Okay, and you see that this allows us to get -15. Okay, and the number here is gonna be not 15, 5. So I have 5, and this guy equal to 40. Okay, I just, use 40 is better, right? So this guy is gonna be 40, and this guy is gonna be plus 80, and this one will be 65. So you see that we be able to approximate this one, and the difference in the production turned out to be 65 units. Okay, and this one will be the end of the total differential. Okay, so that's all. Okay, so this one is the first topic, and you're gonna see this one again. So you're gonna have the assignment, and you're gonna just follow this example, and you'll be able to obtain the final answer or the solution quite easy, kind of.